So now we're looking at the first question. So this is taken right out of your textbook as well, and I could zoom in on this a little. So the vapor pressure, nitric acid, varies as this. So what are the normal boiling point in the vaporization, enthalpy of vaporization? So a couple of things you got to remember here. And we know this from, let's see. You know how we have the standard sort of, and if it's nitric, I guess it would go like that. Chapter 4, you have a solid, a liquid, and a gas. And we had pressure versus temperature. So what we're focusing on here is the vapor pressure. So we are focusing at right here. So all you're doing is you are saying at a certain temperature, you're picking these points, and they want to know what the normal boiling point is. So normal stands for a certain pressure of normal pressure. So to find that one, you're just going to find the temperature of the normal boiling point at some point. But when you graph this, it would normally be a curve, but to turn it into a straight line and get the enthalpy of vaporization out is what we're going to do. So this is just focusing in on the equilibrium that this was studying, right? Various temperatures and pressures. What were the vapor pressures that you were doing? We know that when nitric acid is at its normal boiling point, its vapor pressure will match the normal, which I think is, normal is probably 101,325 pascals. So to sort of speed this along, we remember one of the equations that's very useful for this is the Clausius-Clapeyron, where you had an expression that looks kind of like this. And we'd like to do the indefinite integration. So there's no limits on it. When you do not put limits on this, you'll wind up with a term ln P versus negative delta H vaporization. And you can see how I'm circling this, saying, look, this in straight line formation is plot ln P on the y versus 1 over T on the x. And if you do that, you're going to, this is what I got as my example, but you have to show the graph. So what I will demand is you have to have a printout of your Excel plot, which should return something very close to this. And the line will look like that. So then obviously what you're going to do next, this tells you that minus delta H over R, what I've circled, has to be equal to this number. And then you can solve for delta H. That's basically that. Then what you can do is with this equation of your straight line, right? X is literally a 1 over T value. You know, ln of P, you set that for the normal, right, pressure, which is 101,325. So you'll know this. You can solve for X, which is a 1 over T, and convert that to the boiling point, the normal boiling point.